Interval notation is a very helpful notation to use when what we want to express is an interval, meaning a set of all the values in between a starting and ending value. So if we think about our familiarity with inequality symbols, here we have a less than and a greater than, just separated by a comma. These are both strict inequalities, meaning that if we use a statement with one of these, for example, if we say x is less than 5, we mean the set of all x values that are strictly less than 5. We are not including the value 5, but we're including everything arbitrarily close to it on the left. 4.999999 is in this set, but 5 is not. But there isn't any upper bound that's actually contained in the set because we can always carry those decimal places out further and further and further to find a value that's in that set. If we have a strict inequality, generally that's going to correspond to a round, sort of what we'd call an open interval bracket, which is basically a parenthesis. If we have instead an inclusive inequality, like these less than or equal to or greater than or equal to examples, we call these inclusive. That would be something like x is greater than or equal to 2, for example. This not only includes everything to the right of 2, it also includes the value 2. We use what we call closed brackets, which are these square brackets. So both bracket types indicate that what we're talking about is the interval of values in between the left and right endpoint. So for example, this first interval a, b in square brackets, it's implied that a is to the left of b because we always write the interval endpoints in increasing order. It means that we're including the value a, we are including the value b, and we are including everything in between. This is a closed interval. If we have the interval from a to b with these open brackets or parentheses, then what this implies is that we have everything between a and b, but we are not including the endpoints, which we could designate by these open circles. And of course we can have a combination of the two. We can have an interval that is closed on one endpoint and open at the other endpoint in either direction. The one of all of these that causes the most confusion is this one right here, the open interval. The reason, of course, that it causes confusion, you might already have recognized that this looks just like an ordered pair. It's not. It's not the same thing. This is an interval, and it's the context that lets us know. So there are some contexts in which it's not obvious. An ordered pair is two different variables x, y, and values for both of those variables. An interval AB is an interval of values. It's an infinite number of values, really, because it's everything in between for one variable, right? Maybe it's x, or maybe it has another name, but it's an interval of values for one variable. So let's start using this. If we're looking at a compound inequality like this statement here, this can be read as a between statement. Before we just interpret it simply as a between, we should look at it from left to right and make sure that it makes sense. Both of these inequalities are less thans, and -4 is less than 8, so it does make sense to read this from left to right as a between statement. That said, I will go ahead and mark -4 and +8 on my number line, and I see that the inequality between x and -4 is strict. Because that's a strict inequality, I'm going to use an open bracket. And I see that the inequality between x and 8 is inclusive. Because it's inclusive, I'm going to use a closed bracket. And of course I do want to include everything in between. So I will go ahead and shade in this part. And then to write this as an interval, I just want to copy down exactly what's on my graph. I start at -4, I end at 8, and I use the same bracket types in my interval notation that I use on the graph. Now we'll look at a few examples in which maybe we don't have two numeric endpoints. In this case here, we have x is less than or equal to 6. So 6 is the only number that I'm going to mark on the graph. And less than goes to the left. Less than or equal to suggests a closed bracket. So I will go ahead and draw this in. If I have an arrow on one end, that arrow corresponds to an infinity. What I need to be careful about is making sure that I still get my interval endpoints in the correct order. So I'm going to write it over the arrow, even though it's not necessary, it's helpful for writing the interval notation. Because this goes to the left, which is the negative direction, it's really going to negative infinity. But when I write the interval, I have to write these in order from left to right, which means the negative infinity must come first. This is a really big deal. When the interval endpoints are in the wrong order, it's impossible to know what a person intended, whether they got the sign wrong on their infinity or whether they had the direction wrong of the interval in the first place, right? Or if they had the right interval but just wrote their endpoints in the wrong order. So it's very important to use the notation correctly because sometimes it's the only way that we can communicate what we know. So negative infinity is always a left endpoint. It cannot be a right endpoint. Similarly, positive infinity is always a right interval endpoint. It cannot show up as a left endpoint on interval notation. So I would say having negative infinity on the right is a more common mistake. And the reason it happens is because 6 is what we see first. Sometimes students start to write the interval based on what they see first and then start thinking about how to finish the interval. And that's when the negative infinity ends up showing up on the right. So we want to be careful about that, plan out our interval before we start to write the notation. This next one, x is greater than -1. Greater than goes to the right, and it is a strict inequality, which means we want an open bracket. So this is what our set looks like. We can see that we again have an infinity. This time our infinity is positive, and it's on the right. Those two characteristics always go together, as we were just emphasizing. So I will write this interval as -1, infinity, open interval all around. Oh yes, another thing that I should have mentioned on the previous one is that infinities also always have open brackets. Infinity is not a real number itself. It's a concept. It's an upper bound. We don't ever want to indicate that the number infinity is included in the set, which is what it would mean if we used a square bracket. So that never happens. It's bad notation because we're suggesting in that case that infinity is a real number when in fact it isn't. So we always have open brackets at the infinities. Regardless of what kind of inequality we had, we can see that in this case where we had a closed endpoint at 6 and the only inequality that showed up at all was inclusive, we still had an open bracket at -infinity. Okay, finally with an OR statement, that means we're taking a union between these two sets. So I'm just going to draw both of them on the same number line. -2 is left of 5, so the first thing I'm going to plan out in advance is just where to write these numbers. And I have x is less than negative 2, which is an open bracket and going to the left. And I have x is greater than or equal to 5, which is a closed bracket and reading to the right. Because of the OR, I do get to take a union of these two sets, which means that even though they are two disjoint intervals and there's no way to write them as a single interval, I get to include both of them in my interval notation, and I do that using a union symbol. So the first interval is from negative infinity up to negative 2, open all around. The second interval, I'm going to put this union symbol between them. The second interval starts with a 5 and a closed bracket and goes up to positive infinity, which of course has an open bracket. This, it's not a letter U, it's more like a little open cup, means union. You may have in the past seen union and intersection, which is related to what we're talking about right now, but we don't need to get into an overly formal discussion about union and intersection, just putting it here for reference about where that symbol comes from. It's easy to remember because union starts with U, and the symbol looks kind of like a U or like a cup that's full, right? But in any case, the union symbol is really the only one we're ever going to use in solution sets.